Hello everyone. So thank you for watching this lecture video. So this is about the problems from 211 to 220. So problem 211, it says we want to calculate the probability that this gambler will win the jackpot. So let's check when he will win. Okay. So the story is just okay. Let's say this guy selected four different numbers from 4 to 12 positive integer. So this means like from 1 to until 12, just pick 4 number. Okay. Then the casino will pick 9 number. So casino just from 12 pick 9 number. So the gambler will win if the casino draw all these 4 numbers that the gambler selected. Okay, so let's split these 12 numbers into two parts. Like here, this 4 number is selected by the gambler, and this 8 number. Okay, so from here, the casino from here pick 9. So he will win if this 9 includes the 4. So this means there's a probability from 12 pick 9 randomly, and if there's 9 number include all these 4, so this means there's 4, we pick 4. And then from this 8, we need to pick 5. Right? So this is the probability that this guy will win. So by the way, for calculation, so let's say what is 12 9. So the calculation is 12 9 equal, you can say 12 to 3, right? Yeah, pick 9 and pick 3 the same. So this equal, just multiply 3 number. So here multiply 3 number, and here multiply 3 numbers. So start from the smallest one, the numerator from largest one. So just use this way to do those calculation. So there's a problem is also find a probability. So the employee is sick more than 2 days in 3 months period. So let's say just suppose that n is number of sick day. Number of sick day. Number of sick days in certain period. So let's say this number sick day. So here for each month is percentage distribution with mean 1. Okay. So now let's say here's 3 months. So we know this is also follow norm percentage distribution. So mean is 3. Okay, so we can find this probability. Say we want to find this n is more than 2, so larger than 2, right? So this equal from 3, right? N can be equal 3, then 4, 5, like logically until infinity. So this one we should use this equal 1 minus p. So n equals 0, 1, 2. Right? So n equals 0. N equals 0 is the use the formula, right? Equal 1 minus, so here is n equals 0 is lambda 0 over 0 factorial, so is negative lambda, and so here lambda 1 factorial is negative lambda, and yeah, so lambda square, so 2 factorial is negative lambda. So this equal 1 minus, we can take it is negative lambda outside, so this lambda is 3, so it's negative 3. So here's 1 plus 3 plus 3 square over 2 factorial. So for this problem, we want to find b minus a. So what is b? And what is a? Yeah, what is a? What is b? So a is probability that is this number of car accident at intersection Q. So we can denote this as like Q is exceed this mean EQ. So this is A, and B is just the same question, but at the intersection R. So just R larger than is R. So what is the distribution for this R and Q? So number of car accident at in per week at section Q has a Poisson distribution mean 3. So we can denote it as Q for Poisson distribution. Mean says lambda equals 3. And for this R, this R for Poisson distribution. This mu equal 1.5, right? Okay, so Poisson distribution, we know the expectation is just this lambda and mu. So this b, so actually become b is thus, like b equal p. This probability r is larger than the r. What is r? R is 1.5. And A is probability Q larger than EQ equals 3. So larger than, oh, let's say, can we include equal? Exceed its mean. So exceeds its means larger than, right? Yeah. Okay. So this means, so this just equal P R larger than 1.2. So just start from 2, right? So just equal to 3 until infinity, and this is Q start from 4, 5, right? So those probability, which is 1 minus, right? So this B equal 1 minus P. This R equal 0, 1, 2. Or 0, 1, not include 2, right? And A equal 1 minus P. So there's a Q equals 0, 1, 2, 3. So now we can easily find this do those calculation, right? So this equal just 1 minus r equals 0. So use this formula, e negative lambda, let's say 0 is lambda 0 is 1, so plus just lambda. Yeah, and this is just 1 minus negative mu, 1 plus lambda mu plus mu square over 2 plus mu 3 over 3 factorial 6. Right? So just plug in, let's say what is lambda, what is mu. So lambda equals 3, mu is 1.5. Oh, this equals 1.5, this equals 3. Okay. So let's see again, lambda. Okay, yeah, lambda equals 3. No, I got confused. Lambda equals 3, mu equals 1.5. Yeah. Okay. So here's 3, 1.5. So there's a problem. We want to calculate this as d. So what is d? D is deductible, right? I think it's deductible. Let's see. What is D? Yeah, policy B has a deductible D. Yeah. Okay. So now let's see. So we have two policy A and B. So for policy A, deductible is thus, and the loss exponential distribution. So let this x as loss. So loss for exponential distribution. So this lambda we don't know, right? So lambda we don't know. Okay. So the question is for A, we deductible this for A. Okay, the deductible is 1.44. And for B, deductible is, let's see, is D. Okay. So what is their relationship? So relationship is the probability that under this policy the insurance will pay some money is thus. So this means like policy pay. So here, what is the probability for pay? Pay is means loss larger than this, right? So probability for pay is actually is x larger than 1.44. So this probability equal, so for exponential distribution, this equal e negative lambda multiply this, so 1.44 lambda. Okay, so this equal, so from here we can find the lambda. Yeah. Okay, so then under the policy B, the probability that the company will pay some money is okay. So company will pay this. So we know this, like probability x larger than D. This probability is equal to negative lambda D. So this equal 514. of 512. So we want to find D. Yeah. So the question is D equal what? So we can find lambda first, then plug in, right? So actually here we don't care about the lambda. We just focus on this D. So let's say we just check this. Okay, negative lambda D, so equal negative lambda 1.44. So this is D over 1.44. Okay, so this part, so this equals 0.64. So we get this 0.64 is this power D over 1.44 equal 512. Right? So we just take a log. We can find that. So D over 1.44 equal this log, right? Log base is 0.64. And this number we can calculate it. Let's say it's equal L in natural log like a 0.51412 over L in 0.64. So we use the calculator to find this number, then we can find this D. So D equal just 1.44 multiply this, right? So multiply this number. Okay, so we have this x, the size of a crane. So we denote this as x. So this x has this density function. Okay. Okay. So we have this. Let's say like a probability for the x less than equal this. Okay, so then we can find this C, this A, right? So we can find this. So what is the question? We need to calculate the probability that this size is greater than 4. So what we need to find is this x larger than 4. We want to find this. Okay, so for this condition, so we can check out this probability x. So this is just equal like 0 to 3.74 and CXA dx. So this equal this number. So this one we can integrate out. This equal. So this equal. This just some math, right? We put it to here. This equals C XA integrate out is A plus 1. And this numbers A plus 1. So we get this equation. And what we need is find this x larger than 4. So larger than 4 means from 4 to 5 CXA. So this equal just CA plus 1. So this equal 5a plus 1 minus 4a plus 1. Right? Okay. So here we need this condition like this. Suppose we regard this equation 1, and the other equation is this is density function between 0 to 5, right? Yeah, 0 to 5. So we have this cxa dx equal 1. So this meaning like c a plus 1, then 5a equal 1. Okay, so we can say like this just equal 1 minus c a plus 1 and 4a plus 1. Okay, so we need to find this. Find this. So maybe we just check. There's two equations. Find the relationship between C and A. Okay. Yeah, like let's say we can find this A from equation 1 and 2, right? We just equation 1 divided by equation 2. Equation 1 divided by equation 2, we get this. So we can cancel C. Okay, so this equal like 3.75 over 5 A plus 1 equal 4A71. So from here we can find this A. So we can use maybe we should take a log, right? Yeah, take a log A plus 1. Yeah. So here just some calculation. A plus 1 equal this log. Log base is this. This A plus 1 equal. So use calculator, we can find A plus 1, find this A. Then plug in here. Yeah. Okay. And so this one we can regard this like we use equation 2. Yeah. We don't need to find this C. Yeah. So let's see. So here a little bit of math. Like we say if this is 5, this is 1. So this is 4. No, here's plus 1. Yeah. This is 4. So this equal just 4 over 5 A plus 1. Okay, we just divide by 1, so this 1 is this. Yeah, right? Okay. For this problem, so what we want to find the expected amount of expected payment for this company. So there's a payment. So we just check what is the payment. Okay, so payment for each time is 5,000, but the number of those claim number of claim follow this distribution with mean is C. Okay, so we just so this in so number of claim can be 0, can be 1, can be 2, can be infinity, right? Okay, so there's a payment. 0 is 0, yeah. Okay, so if it says let's say insurance policy will pay nothing for the first claim. So first claim, this is 0. So if you have it has 2 claims. So first claim pay 0, second claim pay 5,000. So here's 5,000, and then here is 2 times 5,000, right? We have like a first claim, they will pay nothing. The second claim 5, third claim 5. Okay, so we know if this is K, then here just K minus 1 times 5,000. Okay. Okay, so the expected payment, the EP of each payment, so equal, we can use this equal summation for probability that N equal K. Then they will pay is K minus 1 times 5,000. And this is K start from 1 to infinity, right? Or can be 2 to infinity. So there's 1 to infinity, 2 to infinity, same. So we just put this K equal 1 to infinity. Okay. So there's a constant 5,000. We can take it out. So this equal 5,000. So for this summation, we just split into 2. So this equal K equal 1 to infinity K times P N equal K. So minus summation K equal 1 to infinity P N equal K. So for first one, what is first one? First one actually is mean for, so this equal, first one is just the expectation for this N, right? N equals as multiply, and this one, so total probability besides N equals 0. So this equal 1 minus P N equals 0, right? So what is N? What is the distribution for N? N for, we say for Poisson distribution with mean is C. So we know this is N equals C. This is called just this is C, and this is, so this equal 1 minus, so N equals 0. 0 is just negative C, right? Okay, so then what is C? What is the mean? What is the parameter? Is C. So we just check from here. Let's see. The probability that non-claim, no claim, is that. So no claim, just that we know n equals 0 actually. Like this equal 60. So what is n equals 0? N equals 0 is e negative c equal lambda 0 n. So this just equals 0.60. So from here we can find c. So there's c just equals this, right? Negative L n 0.6. So now we can plug in this c here. So we say c equal negative L n 0.6. Okay. Yeah, and this one, this is actually 0.6, right? Okay. So for this problem, we want to calculate this b. Okay, so what is b? So b is something that's the loss for uniform distribution between 0 to b. So the policy has a deductible 180. So here expected value of the unreimbursed portion. So what is, suppose this unreimbursed portion is y. So what is y? So this x loss. So what is y? So y actually is from 0 to 180 is x, right? Not insured. Insurance will not pay that. And so from here to here, 180, right? Okay, so we find this expected value is y equal. So this y is unreimbursed. So y equal 144. So from here we can find this b. So y equal 144. So what is y? So how can we calculate y? So y equal between 0 to 180. This is x, right? So that's the function 1 over b dx. So plus, so larger than 180 payment reimbursed 180. 180 multiply the probability is b minus 180. Okay. So for this, so we can get this equation of this is 44. So equal this part is 2b over 180 square plus b, so 180 b minus 180, right? So solve this equation, we can find b. Right? So let's say we just multiply 2b, yeah, 2b. So let's say multiply 2b. So 2aab equal 180 square plus, so we multiply 2b, right? So here become 360 b minus 180. Okay, so we can easily find this is b, right? So let's say go to b here. So 360 times 180 minus 180 square equal 360 minus 288A B. Okay, so we can easily find this is B. Yeah. So if we put this as a formula, maybe we don't need to do step by step. Use calculate, put the whole formula into calculate. We don't need to simplify, just like that, like 180 minus 180 square. Put the whole thing into the formula. So this number divided by this number. Okay. Okay. So this is probability we want to find 12% percentile. So this means, okay, so what is those things? So those working lifetime, so we denote this as x. So what is the distribution for x? So this x follow normal distribution. So x follow normal distribution, right? X follow normal distribution with means 10 and variance 4. So standard deviation is 2. Okay, so we want to find this cutoff point such that this is 12%. Okay, we want to find this cutoff point. Suppose the cutoff point is A. So we want to find this is A. So such a problem is easy problem, right? This is for normal distribution. So at the first result, we want to find this A. So at the first, we just changing this as a standard normal. Okay, so this equal P C less than, so A minus 10 over 2. So check standard normal, check the standard normal table, we can find this number. So A minus 10 over 2, so equal that number. Okay, so this number you just check from table, from C table. So for this problem, we have two things, profit A and B. Normal distribution, same mean, but the standard deviation of variance. So we say variance are different. So A follow normal distribution with means mu and standard deviation sigma 1, suppose. And B follow a normal distribution, same mean and standard deviation sigma 2. So this sigma 2 and sigma 1, their relationship is sigma variance, like sigma 2 square equal 2.25 sigma 1 square. So we say like a variance is that, like variance of B is 2.25 times the variance of A. Okay. So we find for A, find 14th percentile. So there's a percentile. So we find so there's a percentile equal P percentile for B. So we find P. So 14th percentile is this point. Like let's say 14 so equal P. Suppose that the point is A. Okay. So this one, So changing to standard normal, so equal c less than a minus mu over sigma 1. So from standard normal, we can find this cutoff point. Sigma 1, this should be equal, let's say, equal, we say equal alpha 1. So we say this is from the table. Okay, so let's say, so we want to find percentile of B, so find this P. So we find this P is thus, like B less than A. Right? So this one changing to standard normal. So here is the A minus mu over sigma becomes sigma 2. Yeah. So we want to find this. So this sigma 2 equal what? So sigma 2 we just change to sigma 1. Yeah. So this equal C less than A minus mu over sigma 1. So times sigma 1 over sigma 2, right? So this sigma 1 over sigma 2 is this 1 over 2.25. Take a square root. So this number equal this first number. We already checked this for alpha 1 times this 2.25. So we can find this number, then check the table, we can find this probability. So this probability is just a percentile. Okay, so for this problem, we want to find values, giving that the value is at least 10. So here this x just start from 5, right? So we can say this start from 5. This is just the exponential distribution with lambda is equal 1 over 5. So only difference is just this one not start from 0, just start from 5. Okay, so if this condition, if we just start from 10, so this is still an exponential distribution. Okay, because density function is same, just adjusted, right? So let's say like here, density function is just lambda is negative lambda x. So if x larger than some number, so we just density function is still just like that, only constant change, just adjust it. Yeah. So we let like x, let x equal 10 plus t, right? So this is just equal some constant is negative lambda t. So this is density function. So this case should be lambda. Yeah. So we say like conditional distribution, like conditional exponential distribution, still exponential distribution. Okay, so by now this problem is really easy, right? So this, suppose this is y, so y is just equal x under this condition. So this y is exponentially distributed. Exponentially distributed. So value is 1 over lambda square. So this is lambda 1 over lambda 1 over 5, so that's equal to 25. Okay, so those are problem from let's see, the problem from 210 to 220. Okay, so we can stop here. Okay, so thank you.